So this section is going to kind of take you back to the beginning where we had to prove whether or not lines are parallel. Okay? So basically, show that 1 is true at the top, right? So we have alternate interior angles congruent, alternate exterior angles congruent, corresponding angles congruent, and CIAs are going to be equal to 180. Okay, that's what we're going to try to do here, but now we're working with polygons. And we know a lot about polygons at this point. We know how to find all sorts of angles. So how is this different than anything else? Is that there are no numbers there. You see that? Not a single number on there. So you're going to come up with numbers. Okay? You're going to bring that polygon to life and bring angles into the mix. So is AB, is this line right here parallel to that line right there? Right? If you want to think of it this way, CD actually goes right along the base here, and AB is like a diagonal, quote unquote, right? So how would we do this? I will cut to the chase right away. I tend to use CIAs and alternate interior a lot. Those are the two I use for polygons the most. Because there's very few instances where you're going to have alternate exterior, very few where you have corresponding. So I kind of tend to focus on those two when it comes to these types of questions. Okay. So this is your diagonal. So we can use inscribed polygons in this case. What I'm going to do is I'm going to find this angle right here and this angle right there and check if they add up to 180. That's what I'm going to do. Okay? So angle ACD. So let's do the math here. Angle ACD. I know you don't like three-letter notation, but every once in a while I want to torture you with them because we need to be comfortable with that. Okay? So angle ACD is going to be equal to, how would I find that? What kind of angle? We have a name for it, right? Interior angle of this big polygon here. So 1, 2, 3, 4, 5. N is equal to 5 for the big polygon. So this would be 5 minus 2 times 180. All of that divided by 5. Angle ACD. Mr. Jackson, could I have called it something else so I don't have to use three-letter notation? Yes, you can. So that's 3 times 180 divided by 5. Angle ACD is going to be 108. No surprises there. Some of the numbers you'll just memorize. Like it's a pentagon. I know it's 108. So important to us, but we're not done yet. Next, I'm going to find this angle right here. How would we call that using three-letter notation? I would go CAB or BAC. It doesn't matter. So angle BAC. This is a trapezoid, correct? An isosceles trapezoid. How do I find that angle again? I go 360 minus 2 interior angles divided by 2. Let's go back here and just say that this is the interior angle. Oops, what happened to my pen there? I'm just writing down here if you can't see it. Interior angle of the pentagon, this one. So I use that again. So angle BAC is 360 minus, yeah, you can actually, if I just want to show you, right? Just go 144 divided by 2. So that's 72, right? 72 degrees. So angle BAC is 72. You can tell already they're supplementary, right? Which is what we suspected. But now you've, without a doubt, have proven it that they are. Okay, so angle ACD plus angle BAC would be 108 plus 72 is 180 degrees. AB, let's do the first part. Consecutive interior angles are equal to 180, comma, therefore AB is parallel to CD. This is your concluding statement here. It doesn't have to be done in that exact order, but that's how you would prove it. As you can tell, alternate exterior wouldn't have worked here. There is no alternate exterior immediately visible. There is no corresponding, okay? Look up here for to the board just for a minute. Some students say that this one corresponds to that one. It's not true. Because watch, you would have to extend this transversal, and then you could say that this one corresponds to that one, but you don't have that inside the polygon, right? You don't have the corresponding angle, so be careful the assumptions you make. That's why I think CIAs and alternate interior are the most common ones when you do these types. I'm going to stop there. What I'm going to ask you to do, I'm just going to ask you to try one, okay? So try this one. You try. I'm going to tell you that this one is going to require a bit more work. But this is the good news here, guys. You know how to find every single angle that I have on there. You know how to find those. You should at least. Okay? So maybe if you're not sure, just try finding a whole bunch of angles and then see a pattern. It's like, oh, wait a minute. These two are alternate interior. These two are CIAs. These two are whatever. And then solve. Okay? So at the very least, I need you to find angles A, B, C, like the lowercase ones. At the very least. I would like you to make a conclusion as well. And that is that. Okay? I'm going to leave it like this today. I wanted more.